My name is Pranav K. Raju, and this is Physics Lab 3, Black Hole. The purpose for Part 1 is determining the mass of the black hole by modifying the provided starter code that simulates the interaction between a star and a black hole. For Part 2, the purpose is to simulate orbital motion in a planet-moon system and explore the effects of gravitational force on a moving object. We are attempting to achieve a figure-8 orbit while ensuring that the spaceship is influenced by both the moon and the planet. For Part 1, the system is a black hole and the star, while the surrounding is a space. For Part 2, the system is a spaceship, and the surroundings are the planet, the moon, and space. Throughout this lab, we are directly applying Newton's second law of motion, through which we get the position and velocity update formulas. Additionally, we will also be using the gravitational force formula. In addition to that, we will be using F parallel, which is the force along the direction of velocity, and F perpendicular, which is the force perpendicular to the direction of velocity, determining direction. Here is a preview of the results. In Part 1, we determined that the mass of the black hole is 1.85427 multiplied by 10 to the power 34. And in Part 2, we determined the speed of the spaceship, x and y, to be 24,800 meters per second. Procedure. In Part 1, using the starter code provided, we determined the initial values for the star, such as the mass, delta t, etc. We then determined the initial/final velocity and the initial/final momentums. Then, using this Newton's second law of motion, we calculated the net force as well as the net force parallel and net force perpendicular. And finally, using the values found above, we determined the mass of the black hole. In Part 2, using another starter code provided, we need to determine various values before we can determine the ship speed required. First, we determined the gravitational force on the spaceship by the planet. Then, we determined the gravitational force on the spaceship by the moon. Finally, using the values above, we determined the net force on the spaceship. Then, we used Newton's second law, the velocity update, and position update formula. And then finally, we determined the speed, x and y, of the ship. Here you can see is the starter code used for Part 1 of the lab. And in the screenshot on the right, you can see most of the important calculations done in order to find the mass of the black hole. And here is the output of the code shown in the previous slide, where you can see that the average mass of the black hole was determined to be 1.85427 multiplied by 10 to the power 34. Now, here is another starter code provided for Part 2 of the lab, and in the screenshot on the bottom right, you can see the main calculations done in order to determine the various forces and ultimately the net forces. And here's the output of the code shown in the previous slide. Through a trial and error process, I determined the speed of the spaceship to be 24,800 meters per second, and as you can see, at that speed we obtained a figure close enough to a figure 8. Sources of error. As it is a simulation, it's not entirely accurate and it does not take into account other external forces such as other planets, etc. For Part 2, finding the speed was entirely a trial and error/guessing game, as there is no single correct answer for that. What does it mean and what if? For what does it mean, net force and the rate of change of momentum are technically the same thing, but when you look at their individual components, net force is the total force of an object influencing its speed and direction, while rate of change of momentum is how an object's momentum, mass multiplied by velocity, changes over time. The parallel component affects speed, while the perpendicular component affects direction. And for what if we were to predict the motion of the entire system consisting of a black hole, a star, a planet, and a moon, we would need to include the gravitational force caused by the black hole, as well as the forces exerted by the star, the planet, the spaceship, etc. The black hole's gravitational force will be the most dominant. Thank you.